we begin to realize how straight lines are the backbone of all types of analytical procedures and all types of curve plotting. For example, let's suppose we were studying this particular curve, and we wanted to know what was happening to that curve in a neighborhood around the point P. Let's draw in the tangent line to the curve at the point P. Notice that this line that we've drawn serves as a wonderful approximation curve itself if we stay close enough to the point of tangency. In other words, notice how much we can deduce about this curve if we study only the straight line segment at the point of tangency. Of course, the approximation gets worse and worse as we move further and further out. But in a neighborhood of the point of what's going on, notice again then that the straight line is an important building block. By the way, again, we use straight lines in a rather subtle way in something called interpolation. For example, let's suppose I go to a log table and I look up the log of 2. I find that the log of 2 is 0.301. I look up the log of 4. I find that's 0.602. Now I look for the log of 3 and I see that it's been obliterated. I don't know what it is. So I say, well, let me guess. 3 is halfway between 2 and 4. Therefore, I would suspect that the log of 3 is halfway between the log of 2 and the log of 4. And so halfway between here would be about, what, 4, 5, 2, roughly speaking. All of a sudden, the obliteration on my book clears up, and I look, and I don't find 0.452. Instead, I find, let's write it over here. What I find is 0.477. Now, you know, this is a pretty big error to attribute to slide rule inaccuracy or trouble in rounding off the tables. What really went wrong over here? And the answer comes up again that unless otherwise specified, the process known as interpolation hinges on replacing a curve by a straight line approximation. In fact, you see, if we were to draw the curve of the logarithm function, we would find that the picture is something like this. And when we looked up the log of 2, this height is what we found in the table. When we looked up the log of 4, this height is what we would have found in the table. If we had looked up in the table the log of 3, this is the height that we would have found. This is the height that's 0.477. Notice that in general, if we go halfway from here to here, we do not go halfway from here to here. It depends on the shape of the curve. The only time you can be sure that you have proportional parts is if the curve that joined these 2 points was a straight line. Okay? And notice, by the way, that by the shape of this curve, the straight line falls below the curve, and therefore the height that we found was to the straight line, not to the curve. That was the 0.452, you see. In other words, notice that we got a smaller than the right answer because we approximated as if it was a straight line that was joining the curve. You see, what interpolation hinges on is that the size of the interval is very small, and that you can assume that for the accuracy that you're interested in, that the straight line approximation to the curve is sufficiently accurate to represent the curve itself.